What we'll do is we'll set these guys up in stormwater channels or creeks, and it is tied to a flow meter. So this is sitting at the bottom of a channel or creek, and there's a sonar signal coming out that's measuring particles flowing by, so it can measure the velocity. There's a pressure transducer that's giving you the level, and then we do a cross section of that, put that cross section geometry into the computer, and it gives us a flow.
Is that like Doppler velocimetry?
Exactly.
Okay. I didn't know they were doing it in rivers now.
Yeah.
I have a book on that somewhere in my office. I don't understand it.
And then we also have rain gauge, so we know when it starts raining how much rain is collecting. So we can actually program this to trigger whenever there's an increased level on the river, in the creek, or if there's sufficient rainfall, it can trigger. And once it triggers, it starts collecting a sample from this, which is sitting down at the creek. And so what happens is, as all these 8 bottles on the bottom here, we program it to collect a sample every, say, 20,000 gallons that comes through. And so it'll collect a little bit of water in each bottle each time a certain amount of water is flowed by. And so as the storm increases, you have increased sampling intervals because there's more flow. If that makes any sense.
Yeah.
And then
and
when
you said I'm just trying to understand. So you said the flow is measured by the increase in pressure by the water, like if there's more of it, and what was the other thing?
Right. Well, so the flow is being measured by this guy here.
Right.
So it's measuring the velocity, and as a pressure transducer, it's measuring the level. So the higher the level, the increase the pressure.
There's like particles in the water going by, and if they're going by faster, that's faster flow. And you're basically using ultrasound, and it's just basically like a mini speed radar gun, essentially, except for it's several of them, and it's actually bouncing little signals off of those guys as they come by, and then they get frequency shifted, and that tells you the flow. It's
great.
Yeah.
And we do a cross section, and we enter that geometry into here, and it calculates cubic feet per second or whatever the flow is.
Is that better than going out in the middle of the night doing?
No comment. At the same time that we have this guy set up, we have these deployed in the same location, and these are measuring turbidity, conductivity, pH, dissolved oxygen, and temperature on a regular basis.
So turbidity is...
Turbidity is this guy. Dissolved oxygen is this guy. pH, and this is conductivity.
Conductivity is, yeah, okay. So how does it do dissolved oxygen?
It's a new membraneless DO meter that I would have to explain.
Yeah, okay. Yeah, it's okay. That always puzzled me how you do that.
And then we have this guy, which actually we use in the reservoirs to look at algal bloom. So this is measuring total coliform and phyton, and then it also has turbidity and all the other measurements. So we can see, we can lower it and do it by depth and do a profile of a lake and see where there's algal activity at certain zones of the lake.
That's cool.
So that's more the the high-tech way to sample.